Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi and a very good morning to all my beloved Form 4 students. Okay, so we can start with the second subtopic of chapter 1. Okay, so 1.2 scientific investigation. Scientific investigation. So in this subtopic. So these are the learning standard. So number one, student able to interpret graph to determine the relationship between two physical quantity. Okay. Second is to analyze graph to summarize an investigation. Okay, and then the third one is to carry out scientific investigation and write complete report. Okay, for the first experiment, we'll be doing simple pendulum experiment. Okay, but with this knowledge, you actually can do a more scientific investigation. Okay, now, so these are the suggested activity. So there are different shape of graph. Okay, that can be that will show the relationship between two physical quantities. Okay, so we have directly proportional, increase linearly, decrease linearly, increase non-linearly, decrease non-linearly, and inversely proportional. Okay, so this one later, it is in your textbook. Okay, need to memorize this also. Okay, then so from the data that is given or from the experiment that you do, from your data that you collect, you can state the relationship between two given variable after you plot the graph lah, and then determine the gradient of the graph. The gradient of the graph normally will represent a physical quantity. Okay, and then also can determine the area under the graph. That also will represent a physical quantity. This depends on what type of graph you plot. Okay, then determine the value of physical quantity from interpolation, and then you can also predict through extrapolation. Okay. We look at one experiment first. Wait. I think I better look at the your textbook. Okay, so in this textbook, I can see 1, 2, 3, 4, 5, 6. 6 type of graph. Okay, 6 type of graph. And vertical horizontal axis of the graph is actually represent a physical quantity, something that can be measured. Okay, that you have learned before, right? So the first graph here is actually a directly proportional graph. See here? Directly proportional. Okay, directly proportional graph. Differentiate them. The second one is increase linearly graph. The third one, decrease linearly graph. Okay, we look at these three first. Okay, when you plot a graph, make sure you write 0. The origin must be labeled. Okay, so you need to label this origin. Okay, 0. If the graph, if you have this type of graph, means that a straight line from origin, so we said that y is directly proportional to x. Okay. Then if let's say your graph is a straight line graph, but it does not start from origin, just like this. So this one is increase linearly. Why we say increase linearly? See, y increase linearly with x. So when x increases, okay, can see y also increase. That's why we say this is increased linearly. To differentiate it from the directly proportional graph. Then here, also a straight line graph, but it does not start from origin, and it clearly shows that the graph decreases. Okay, so this is decreases linearly. Okay, so far okay, right? Boleh ikut na? Now, so graph number 4 and 5, both actually curve graph. So can see this is curve, this is also curve. So if the curve increases, okay, although the shape is different between these two different shape, what I mean is different, this is actually decreases gradient, this is increase gradient, okay? But when we state the relationship between y and x here, so we use the same interpretation, okay? So here is y increases with x. But if you see the graph gradient, kecerunan, the gradient of the graph decreases just like this. This one is, sorry, this is, decreases. Lengkung like this. So this is what we call as decreases, y decreases with x. Boleh faham? Can or not? Okay, when I say gradient decreases, I better write here. Takut cikgu sebut, cikgu dalam kepala betul, but cikgu sebut salah. So this one, do you understand what is the meaning of gradient? Gradient. In BM is kecerunan, slope, sloping, slope. Okay, so if let's say you imagine yourself, katakanlah you run from this point, lari, naik atas, okay, you run upward, and okay, you run upward. Which track is getting harder and harder? Is it number 1 or number 2? If we say this is a track, which one is getting harder? You imagine yourself running on a hill, there's the slope of the hill like that. So which one is getting harder? Number 2. Yes, number 2. So when it is getting harder, so it means that the gradient increases. So the second graph actually showing gradient increases. Okay, so the first graph means gradient decreases, which means the gradient of this curve graph is not constant. Again, not constant. Now look at this one. So you imagine yourself, cikgu padam this one first. So you imagine yourself running from here. Which one is getting macam more dangerous? More scary to turun bawah? Which one? More scary is the first one, right? Yes, so the first one. So this is more scary compared to the second one. So means that the first one has the gradient actually increases. Okay, so this one gradient increases. Here gradient decreases. Okay, wait, we look at this. So what can you say about the gradient of this graph? Let's say you run from here. Is the gradient increase? Is the gradient increases? Or is the gradient decreases? Or there is no changes in terms of gradient? Yes. Can also look at the second graph. Okay, let's say you run from here, run up, and here also, go down. These are all straight line, okay? So what can you say about the gradient of the graph? Any changes in the gradient or not? No changes? Any changes or not for the gradient? You can use microphone. No changes in the gradient. Yes, there is no changes in the gradient. When you run up this track, let's say this is a track, so when you run up, so the gradient is all the time the same. So for this case, we say that the gradient are the same. The gradient is the same, which means this is constant gradient. So we call this as constant gradient, constant. So if you calculate the value of the gradient for a straight line graph like this, the value will be the same. The value will be constant. Either graph number 1, graph number 2, graph number 3, as long as they are straight line, the gradient will be the same. Okay, clear about this? Jelas? But when you see a curved graph like this, the gradient actually changes. So gradient at this point and at this point will be different. Okay, same goes to this. Okay, the gradient is different. If let's say we label this as number 1 and number 2, okay, so gradient at point number 2 is greater compared to number 1. So that's why we say that gradient increase. Okay, because here the gradient is more compared to this. Okay, get the idea first. Get the idea first. Just like this also. So I really hope you can visualize yourself running on that track. You can determine whether the gradient increase or decreases. Okay, it's like this for this point. Katakan here and here. Okay, so point A, point B. B, if you calculate the gradient at point B, so the value that you will get will be smaller. Here, the gradient will be smaller compared to this. Okay. Okay, continue this one first. All right, so when the graph decreases like that, so we say that decreases, y decreases with x. Okay, y decreases with x. And then this is another one, curve. So this actually represent the same data for the same x and y. What I mean is, if you collect data, okay, for x and for y, okay, so we collect data for x and y. First, you plot graph of y against x using this data they already tabulate in the table. Let's say the shape of the graph that you get is like this. After you plot, you get katakana. So these are the point that you get. Then you draw your graph. When I say graph means this one. Okay, you plot your graph using data that you already get from your table. Okay, like that. So if let's say you calculate the value of 1 over x, so means that exactly the same value here, but you calculate 1 divided by x. Let's say here is 2, 4, 6, 8. Katakan 2, 4, 6, 8, 10. Can you help me to calculate 1 over x? 1 over x, 1 divided by 2. What is 1 divided by 2? Okay, 0.5. And then 1 divided by 4? 0.25, right? 1 divided by 6? Tolong cikgu. Okay, 1.67. Okay, so here 1.67. 167. 1 divided by 8? Okay, 1 divided by 10. Okay, 0.1. Like that. So, uh, so it means that you are using this data. Okay, let's say you have your y, your x, y and x. Huh? So you use this, okay, here, and then with the same value of y, okay, for this graph, you will get graph like this. Okay, straight line graph from origin. So which mean now is it? So this graph is the same as the first graph that we looked just now. Okay, for the first graph, here, so we say that y is directly proportional to x. So here we say that y is directly proportional to 1 over x. Okay, so here you can write y is directly proportional to 1 over x. Clear not? Jelas, huh? Which mean y is directly proportional to 1 over x is actually the same as this relationship if you use x. Okay? Because when you plot graph of y against x for the same data here, okay, you will get like this. Okay, so this is inversely proportional graph. Okay, inversely proportional graph. But if you use the same data, but here you use 1 over x, you will get a straight line graph from origin. So we can we can state the relationship between y and x using two methods. Number one, you can write y is inversely proportional to x. You can also say y is directly proportional to 1 over x. Boleh faham? Can understand or not?
Yes.
Boleh, ha? Okay. But in class, we will look at more example of this real experiment and then you can understand better. Okay. So this one is just introduction. All right. Okay. So a, a graph, a straight line graph, a linear graph will have formula. Okay, will have formula. So kejap. I think I better introduce you the formula first. Katakan like this. Then later we look at the graph again. So let's say we have this graph. Okay, so y, x. And then let's say the shape. Okay, like that. Okay, so this graph, when I say graph means I'm referring to this. I'm referring to this line. These are the axes lah. Okay, so when I say graph means that I refer to this. So this linear graph have formula. So the formula is like this. Y equal mx plus c. Okay, y equal mx plus c, where y is the vertical axis, x will be the horizontal axis. Okay, m here is the gradient. Okay, so this m is the gradient of the graph. So gradient have magnitude, means it got number lah, huh? And then c is actually the vertical axis intercept. Now we label the vertical axis as y, so I can say c is y intercept. Okay, pemotongan y. So means that here, the value here is c. Boleh, ha? Okay, now I give you number, so we change it into number. Katakan kita tukar. Okay, we change the axis also. So let's say you do experiment to determine the relationship between length and time, let's say, length and time, or distance and time. So when, okay, relationship between distance and time. Here, this graph, okay, showing, let's say, the relationship between distance and time, which means this is a graph of distance against time. So the first variable mentioned will be on the vertical axis, okay, distance. So can I use symbol, let's say L, I'm using L for distance, let's say, ataupun D lah, okay, right, D, distance. And then horizontal axis is time, T. So when you label the axis, you must write the unit, okay? Physical quantity and unit. So distance, this symbol for distance, and then unit is meter, okay? Time, what is the unit for time? Unit for time is second, like that. And let's say the value here is 0, and then let's say this is 10. Okay, then after, katakan, let's say I just put here, after 5 seconds, the distance travel is, let's say, 20. Yeah. Now, so what is C? Now, can we change the equation following the graph that we have? So the equation become what? What is Y now? Y now is actually D. And then X following this graph is T, right? And then C is 10, okay, the y-intercept. So we can change the equation so it become like this. Okay, so this is D equal M unknown, okay, need to calculate it. So X now is time, okay, plus intercept on the vertical axis is 10. Okay, so your equation become like that. So it means that this equation represent this graph. This equation represent this graph. Clear or not? Now, how to determine gradient? So gradient have formula. Okay, to determine gradient, okay, we need to draw a triangle, okay, on the graph like this. Normally we use dotted line, use straight line also okay. All right, so the triangle must be right angle triangle on the graph. And we try to draw as big as possible triangle, okay, like that. So you see, so if you want to determine the gradient, the formula will be like this. Changes in y-axis. Okay, I can put here as, I'm using triangle. Triangle here means changes. Okay, changes in y-axis. Okay, and then here will be changes in x-axis. Okay, but y-axis and x-axis now is already changed name. So y-axis now is actually D. Boleh faham? And then x-axis now is actually T. So need to do like this, delta T. Okay? Boleh ha? So what is changes in x-axis? So it means that the value here, this value, how much is this value? So this is 0, this is 5. So we know that here is 5 seconds. So it means that changes in t-axis is 5. So here, cikgu boleh tulis. Kejap. So I can do like this. Equal 5 minus 0. Okay. And then for the y-axis, changes in d-axis, y-axis is what? So you see here, the height of this is 20. Kan? And then the height of this one is 10. But we just want the changes. So what minus what? Correct. 20 minus 10. Okay, 20 minus 10 because we just want this length. So it means that 20 minus 10. So I can write here. Okay, 20 minus 10. So the formula for gradient M is actually changes in the vertical axis, means that changes in y divided by changes in horizontal axis. Okay, but now since our axis is not y and x, we have d and t. So I can write like this, changes in d divided by changes in t axis. Okay, so can substitute the value. So d is 20 minus 10, horizontal is 5 minus 0. Okay, so help me to calculate. What is the value? What is the answer? 2, correct. So the gradient now is 2. So means that if I want to change this, okay, since we already have the value of gradient m, so the formula become like this, d equal 2t plus 10. So when you see like this, actually you can imagine how is the graph. Okay, because from here we know that the vertical axis is actually this d. Horizontal axis will be t. And then this is c, 10, like that. I can imagine, okay? And then this is a positive gradient. So means that the slanting will be like that. Boleh? So far so good, Boleh ikut, Okay, a shortcut, class, to determine gradient will be like this. Cikgu tukar color. Alright, a shortcut will be like this. So if you know what is the point here, the coordinate. What is the coordinate here, class? What is the coordinate at this point? This point? Correct, 0, 10. Okay, so coordinate is 0, 10. So cikgu tulis 0, 10. And then what is the coordinate at this point? Coordinate. Correct, 520. Okay, so this coordinate is 520. Can put here 520. So actually gradient, okay, a shortcut for you to calculate gradient, this will be y2 minus y1 over x2 minus x1. So let's say we refer the first point as the x1, y1. Okay, so the second point will be 2 lah. So this is x2, y2. So can see or not? Okay, 20 minus 10 is this. Y2 minus y1. And then divided by 5 minus 0. That is x2 minus x1. Is it clear or not? Jelas? Okay, so this will be a simpler way for you to determine the gradient. Okay, you just need the point. Okay, titik. Actually, if you use other point, as long as the point are on this line, okay, you can use this point and this point, okay. As long as the point are all on the same graph, you will get the same gradient. What I mean is, let's say you use this point and this point. So it means that your triangle will be like that. Small triangle, but still you will get the same value. As for this graph, still you will get 2 for the gradient. Kan? Gradient 2. So as long as you are you use any point on this graph, you will get the same gradient. So that's why we say if the graph is a straight line graph, so the gradient will be constant, same gradient. But in exam, you cannot use the point that is too near. What I mean is when you draw your triangle, the triangle is too small like this. Why? Because if you do this, means that the range of data that you get is actually too little, terlalu sedikit, tak banyak. But if you use bigger triangle like this, right? So these are the range of data that you use. So means that more accurate. Okay, more accurate. Faham? All right, good. Okay, wait. So if the graph is slanting, like what we have now, slanting, okay, like this, or like this, or like this, okay. So all of these are positive gradient. All will be positive gradient. Okay, we look at another example. Another example. Okay, so we plot another graph. So let's say we have acceleration against force, like that. And then let's say your graph, it cannot be acceleration against force. It will be directly proportional. I use any symbol lah, huh? I don't want to make you confused. I think I better use other symbol. Just use P and Q. P, Q. So the graph of this, let's say, like this. Okay, I just simply put a number here. Let's say 50. And then here, let's say 10. Okay, like that. So here 0. All right, can you calculate the gradient of this graph? Try to calculate the gradient. Write your answer. Okay, you can use the shortcut to calculate the gradient by using the point. Okay, so this is 0, get the coordinate, 0, 50. This is 10, 0. And when you use these 2 points, you are using this triangle, which means most of data, all the data is in your calculation. Okay, so this is tick 1 mark for the gradient, because gradient normally 3 marks. Okay, then so the gradient m equal to changes in y. Okay, you can write y2 minus y1 divided by x2 minus x1. Okay, so means that 50 minus 0, okay, divided by here 50 minus 0, so divided by 0 minus 10, like that. Okay, because if you assume this is x2 y2, so the other one will be x1 y1, x1 y1, like that. Don't mix up, jangan bercampur. Okay, so as for this graph, it will be 50 divided by negative 10. So what do you get? Negative 5. So this is what we call as the negative gradient graph. So it means that if the slanting is like this, it's slanting like this. Okay. Okay, these are all negative gradient. That is why when you look at this graph, these two, can see? So this is positive gradient, written there as positive gradient, okay, because slanting like that. But here, kan? So this is negative gradient. Knowledge on this is important when you enter chapter 2. Okay, when you enter chapter 2, the knowledge for this negative, positive gradient, increase, decrease gradient, constant gradient will be very important in chapter 2. So far, okay, can follow? Boleh?
Yes.
Okay, now for this graph, what will be the equation? What is the equation for this graph? Using this just now, y equal mx plus c. So what is the equation? We are using p and q axis now. Okay, since we have p and q, we should not use x and y anymore. Change it. Okay, so y change to, okay, good. So this is p, and then x is q. Okay, and then m, the gradient, -5. Then the y-intercept is positive 50. Like that. Okay, I see your answer. Majority betul lah, huh? QX. Rafiq perlu tukar Rafiq, Q and X there need to write the number lah, huh? Okay, Anjali betul, correct. Okay, now okay already? Boleh faham? Okay, next one. Now, so if we refer to this graph, we know that the vertical axis now is distance. Padang first. Okay, so the vertical axis now is distance and the horizontal is time. So it means that the gradient have unit. Okay, gradient have unit. Now look at this. All right, so the vertical axis is distance, which means the unit for this 20 minus 10 is actually meter. The unit for changes in time is second. So it means that now, since 20 minus 10 is 10, right? 10 divided by 5, you get 2. So the unit also we need to divide, which means the unit now is meter, what? Meter divided by second. So the unit is meter, because for the gradient, see, gradient is vertical axis over horizontal axis. So the vertical axis is meter, horizontal axis is second. So the unit also you need to divide. So the final unit of the gradient become meter. Correct, yes, Wafika, correct, yeah, meter per second. You can write like this, as we explained like yesterday, right? Or you can also just write 2m, bring s up, become like that. So meter per second is the unit for what quantity? Meter per second. What is the name of the physical quantity with that unit, meter per second? Yes, anybody? Okay, length and time, length divided by time. But what physical quantity with that unit? Example, macam if let's say Newton, Newton is unit for force. So meter per second is unit for what quantity have that unit? Velocity, correct. So it means that now the gradient of this graph represent velocity. Do you see or not? The distance here is actually length. T here is time, right? Okay, so refer to what you have learned yesterday when we write speed or velocity in base quantity, so you get L over T. So it means that the distance divided by time, which represent by the gradient of this graph, represent velocity. Faham? Okay, so that is meant by this. Okay, in the learning standard here, you can see here. Determine gradient that represent a physical quantity. Okay, so if you plot graph of distance against time, okay, so the gradient will be meter. Okay, gradient is vertical axis over horizontal axis. So the unit will be meter divided by second. So means that meter per second. So the gradient of this graph, okay, will be represent velocity. Okay, that is meant by this. Okay, determine the gradient of the graph that represent a physical quantity. Clear or not? Jelas?
Yes.
Boleh, ha? Okay, next one. Look at this. Determine the area under the graph that represent a physical quantity. This is another one. Okay, what is area under graph? Okay, come, I give you example. So let's say we have another graph. Kejap. Okay, I love to use graph of velocity against time. This will be interesting. This is actually chapter 2, but you know this earlier will be good lah. Okay, so let's say we have velocity against time. What is unit for velocity? Velocity unit? Is it meter? No, it should not be meter. Meter is unit for length, distance. Velocity? Meter per second. Yes, correct. Okay, meter per second. And then time is second. And then let's say we have, okay, let's say this is a graph of you drive a car, katakan. So the car move like this. Okay, then constant velocity, like that. Katakan just like that, a simple one. So let's say this is 5 seconds. We use second lah, easy to calculate. But it can also use minute, but then you need to change it into second. Alright, so let's say here is 20. And then let's say here 50, like that. Now, if I label this as A, B, C, which point of the graph have constant gradient? Constant gradient. Constant gradient. Where's the constant gradient? Is it AB or BC? B to C? A to B? Okay, you need to imagine how you run on the track. How hard it is when you run on that track. Katakan here and here. Which one is harder? Which one is not hard at all? Okay, so here actually this is constant gradient. What about this? Any gradient here? Any gradient at BC? No gradient. Very good. Betul. So gradient at BC is 0. So okay, so here this is gradient equal 0. Okay, but AB is constant gradient. All right, so first we try to calculate the gradient first. From A to B. What is the gradient for A to B? So cikgu tulis here M. I'm using symbol M for gradient. So gradient AB. Okay, what minus what divided by what? Okay, use the coordinate as what we explained just now. Gradient at AB. Coordinate first. Coordinate here and here. Yes, is it hard? Okay, coordinate at B is 550. Betul, correct Jaden. 550. Coordinate at A? Betul, but you still need to write. Okay. So gradient 50 minus okay, 50 minus 0 divided by 0 minus 5 or 5 minus 0? Don't get confused. Correct. Okay, jangan confuse because you need to use the same point. What I mean is if you refer this as x1, x2, x1, y1, this will be x2, y2. Okay, so don't mix, jangan campur. Okay, so here will be 5 minus 0. Okay, so the answer 50 divided by 5 berapa? 10, right? Okay, so what is the unit of the gradient now? What is the unit? If you can answer this, wah, memang boleh tahan. Okay, some student form 5 also still blur with this. But hopefully they learn from this video also. Okay, so what is the unit for the gradient now? Gradient of AB. Don't be afraid to try. Try. M as negative 2. Okay, I see Angeli answer. Okay, ada jawapan lain? All agree with Angeli kah? Okay, senang. So if you want to determine the unit of the gradient, you just need to focus on the vertical axis. You divide unit of the horizontal axis. So it means that this M as negative 1 divided by S. Okay, so maksudnya M as negative 1 divided by S. So you can bring S up, so it become M as negative 2. Okay, so the unit for the gradient now is M as negative 2. Now, M as negative 2 belong to what physical quantity? What physical quantity have that unit, M as negative 2? Refer to the table that you already done yesterday. MS negative 2, unit for? Correct. Good, Nazira. Yes, MS negative 2 is unit for acceleration. So which mean, if you have graph of velocity against time, okay, so the gradient of the graph will represent acceleration. So this is acceleration. Acceleration. Okay, so means that the gradient of this graph is actually acceleration. Faham? Okay, you already see two graph, right? Distance against time, velocity against time. So the gradient belong to different physical quantity. So in other words, you will see question like this. They will give you a graph, and then from the graph, you need to determine acceleration. They did not say either you need to determine gradient or area under graph. They just ask you to determine acceleration. So you need to know where can you get the acceleration from. So now you know the acceleration, can get it from the gradient of the graph. So you calculate the gradient. Clear or not? Jelas? Okay, next. Calculate acceleration from B to C. Cuba, try. Calculate acceleration from B to C. Okay, by using from this graph, determine the acceleration from point B to C. The one that you calculate just now is acceleration from A to B. Now we focus on B to C. What is the acceleration? That's the answer is on the screen already. Jaden already typed the answer, waiting for other student to respond. Now, what is the acceleration from B to C? Okay, cikgu nampak Zahra pun dah ada. Science already. Brian, dah. Correct. 0. Why 0? Because now you already know that the gradient of the graph represent acceleration, kan? So if the question asks you to determine acceleration here, okay, we just need to look at the gradient. Since here no gradient, you can prove by calculation, boleh kira, okay, using coordinate. So here, the coordinate here is 20, 50, kan? So the gradient will be, okay, changes in y-axis. So y-axis will be 50 minus 50 divided by 5 minus 20. 50 minus 50 already 0, ba? Okay, so that's why the gradient is 0. So which mean, I can write like this. So acceleration of B to C is equal 0. Now, if you look at this point, so this is considered as initial velocity. This is considered as final velocity. Formula for acceleration is like this. V minus U over T. This is final velocity. Final velocity, this is initial velocity. So final and initial velocity are the same. 50 initial, 50 final. So here becomes 0. 50 minus 50. So acceleration is 0. I hope you can follow. Okay, ada soalan? Any question? No question, Okay. Let's say we have this. let's say this is a graph, means that gradient 0. Okay, at all time, let's say gradient is 0. So this is a graph, katakan this is y, this is x. Where is area under the graph? When I say graph, I actually referring to this line. So area under the graph will be area under this line until it reach the axis, horizontal axis. So it means that the area under this graph is this point, this part. This is the area, this is meant by area under graph. So let's say you have different shape of graph. Can also have a graph like this. Okay, so when we say area under the graph, it refer to this. Boleh ha? Okay, we can have other shape of graph. Macam-macam shape lah graph. It can be trapezium also. Katakan trapezium like this. Can be like this also. So when we say area under the graph, it refer to this. And your graph also can have the graph also can be like this. Two side. So means that this is your y-axis, x-axis. So if two side like this, so the area under the graph will be this, and also here. This is under the graph because these are the graph that you refer to, and then below the negative side of y. So this is the graph. So when we say area under graph, it will be the area in between the graph and the horizontal axis. So this is the graph, this is the horizontal axis. So that's why like that. Boleh faham Can Okay. Let's say this is cikgu simply bagi nilai. So let's say we have force here. Force, and then let's say this is Newton, and then let's say this one is time, so this is second. Okay, now so if I have a value, I think better give this one first. So let's say this is 20, this is 100. What is the value of area under the graph? Here 0. What is the value of area under the graph? Let's say this is meter. This is meter. So it means that this is 20 meter, this is 100 meter. What would be the area? Magnitude of area. Can you calculate? How to calculate area? 200. How you get 200? How do you get 200, Jaden? No. $2,000. Okay. So the area under this graph, okay, area under this graph means that this rectangle, use your mathematic formula. So means that 100 times 20. So you get 2000 like that. Okay, and you have unit meter, right? So this is meter times meter, so the unit becomes square meter. Boleh yeah, length times length, width times length. This one okay Now, if you have this area, katakan here I just give, let's say 100, this is 20, this is 0. Sama 20. Let's say this is 10. What will be the area under the graph? So look at the shape first. It's a right angle triangle. Cun-cun lah, right angle triangle. Formula? formula for area for triangle. So the area formula is half times base times height, right? Okay, base is 10. Height is 100. Kan? So you get 5. So means that 500. Okay, now what is the unit of the area under the graph? Just now, the unit meter times meter. Okay, now what is the unit of this special graph, force against time? Area. Unit also with times. Okay, ingat lah. So means that here will be Newton, this is second. Alright, so what you need to know now, when you want to determine the unit for the area under graph, you need to times vertical and horizontal axis unit. If you want to determine the unit of the gradient of the graph, so you need to divide vertical divided by horizontal axis unit. Clear? Jelas? And if you want to calculate the area under the graph, you need to refer to what is the shape of the graph. If it is like this kan, rectangle, so times it direct. If it is a triangle, so need to have half in front, half. Formula. If the shape of the graph is trapezium like this, so you need to use the formula for trapezium. Okay, means that half, you need to know what is this, right? So let's say this is A, this is B, okay, and then the height, let's say C. So the area of this trapezium using formula, this formula A, half A plus B times C. Like that. Area, unit, U times. Boleh? This one also the same thing. So this is trapezium. Okay, let's say you want to determine the total area under the graph. It will be this plus this. But we will look at more detail about this graph in chapter 2. Okay, now no need. Okay, now just at least you get it. Okay, sedikit. Not too detailed, otherwise you give up later. Okay, now look at this. So can you calculate the area under this graph? Cuba. Calculate area under the graph. The whole area under the graph means that here. So you need to know what shape is this. If you don't want to use formula for trapezium, also can. You can divide this into two parts. Okay, so we have triangle. Triangle. Part 1 is the triangle, and then the second part is the rectangle. Like this also can, campur. Okay, try calculate. Area under graph. 750, semua dapat yang sama? A to B is 125. A to B 125. Try first, try first. Betul lah, 125 lah. Correct, 125. And then area under BC. You get 750. Kan? So campur semua. 875. Do you get that or not? Dapat nah? Okay. So now what is the unit? What is the unit of the area under the graph now? Is it meter S -2? Check again. Area under the graph, bukan gradient. M2, check again. Area under the graph. So unit you can just times vertical and horizontal axis. So unit of the vertical axis is meter per second. Horizontal axis is second. Vertical axis unit is meter per second times horizontal axis is second. This is 1 lah, huh? So it become S -1 plus 1, it becomes 0, right? So S0 is 1. So means that here is M. Boleh kah? Okay. So means that now the unit for the area under the graph is meter. So I can write here as meter. So what unit is that? What physical quantity have that unit? Distance, right? Distance. Ataupun in this case, it actually displacement. So you see, so if you are given graph of V against T, the gradient of the graph represent acceleration. But the area under the graph represent displacement because this is velocity. Okay, so this is displacement. So it means that the area under the graph represent displacement. Okay, so actually we already done this part. So this one now you already understand. Determine gradient which represent a physical quantity. Also determine the area under graph that represent a physical quantity. Boleh? Okay, so I can say for graph like this, student normally have problem on how to determine gradient and then what physical quantity does the gradient and the area under the graph represent. That one also students selalu ada problem. Okay, and then the unit. Okay, so student sometimes confused on how to determine the unit of the gradient. So be clear about this. This is not hard, tak berapa susah if you really understand. Okay, so to learn physics, number one, you must understand. Okay, after you understand, you memorize. You cannot just simply memorize without understanding. Okay, mesti faham, then easy to memorize. So now, when you want to determine, if you want to determine what does the gradient of the graph represent, you just play with the unit. Just play with the unit. Okay, gradient you divide, area you times. So as time goes by, you will be able to memorize the physical quantity, unit of the physical quantity. Okay, ada soalan so far? So we still have a bit more, the interpolation and the extrapolation. This one is quite easy. Interpolation, extrapolation. This one agak senang. No question lah? Tak ada soalan lah? Okay, sekejap. So means that this part we already covered lah. This one no problem dah eh? Should be okay, right? Should be okay, right? Now here, look at the linear equation for the directly proportional graph. Why there is no plus C? Why no plus C? Why there is no value of C? Correct, C is 0. Okay, yeah, intercept is 0. So that's why you don't have to write plus C. Okay, jelas ah? Next one, look at this. This one should be okay kan? Increase linearly, C, no problem, right? Now you already understand what is that. Okay, tapi your graph tak ada orang lah. That one cikgu tambah sendiri. So make sure you don't add in like that lah. This one also okay ah. Okay, negative gradient. Here mention negative positive gradient. This is positive gradient. This is negative gradient. No problem? So if you really understand kan, this one dah mula senang. Okay, so for this graph, okay, if let's say you get a curve graph, we just say that if you are asked to state the relationship between the two axes, just say like this: y increases with x. Ataupun can also write when x increases, y increases. This one also the same. When x increases, y increases. Like that. Okay. The second one, so here will be when x increases, y? Y what class? Y decreases. So there are two ways to write the relationship of the two axes for the curve graph. Either you write y decreases with x like this, ataupun you write like this, both correct. Okay, but if you see a curve graph that does not touch the vertical or horizontal axis, so make sure this one is inversely proportional. Remember that. So this is y inversely proportional to x. Okay, sikit lagi dah nak habis. So means that when I return next week, empat setia, amanah and ikhlas already can do this experiment. Terus buat experiment lah. When I come the week after next week, okay? So we can do this experiment individually. I think individually. Either individually or pair. I think individually. I will already ask the lab assistant to prepare the apparatus. So we'll be doing this experiment. So make sure you bring your graph paper and foolscap paper. Yeah, and you can write. You can start write the report already. Macam inference, hypothesis can copy from here. Okay, can copy from here. Even the diagram also can copy. Okay, but the procedure you can change it into passive voice. Passive voice report lah. That one is already taught by your Form 1, Form 2, Form 3 teachers, right? And then this table boleh salin. Okay, and then this one also can copy. Then when you come next week, can already start doing the experiment. A bit more here. So now analyze graph to summarize an investigation. So number one, they will ask you to state the relationship between the two variable. So state relationship between the two variable depends on your graph. Okay, we already look at directly proportional, inversely proportional, increase linearly, decrease linearly, increase decrease graph. So that is the answer for this. Okay, let's say they ask you to write the relationship. Just look at your graph and then refer to what you have learned just now. All right. Now, next one is determine gradient. Okay, gradient also we discussed already. Hopefully, you know the gradient of the graph normally have unit. Selalunya akan ada unit. But there are some condition where the gradient does not have unit. Can you guess when? When will the gradient of the graph have no unit? Yes. When will the gradient of the graph have no unit? At most of the time, the gradient have unit. But in some cases, the gradient have no unit. Okay, I read jawapan Jaden. When the gradient is a straight line, no. When the graph is a straight line, no. If you say 0, just like just now, right? Katakan the graph is like this, right? Okay, 0 gradient, tapi still ada unit. Means that the gradient is 0, depend what unit. Maybe 0 meter per second per second. Still got unit. In what cases gradient have no unit? When the vertical axis and horizontal axis have the same unit. If this is meter, this is also meter. So meter divided by meter, it will be 1. Faham? Ah? So only when the vertical axis and horizontal axis have same unit, then the gradient will have no unit because they cancel. Other than that, okay, gradient will have unit. Example, let's say the vertical axis is Newton, horizontal axis is second. So what is the unit for the gradient? Faster, faster. What will be the unit for the gradient? If vertical axis is force, Newton, horizontal axis is time, second. Yes? Cuba, salah tak apa. Why not respond? NS? N per S. Okay, it should be Newton per second. Newton per second. Ataupun Newton second negative 1. Okay, let's say the vertical axis is joule. Horizontal axis is meter. What would be the unit for the gradient of the graph? Correct, joule per meter. Okay, joule per meter. If you want to write, you don't want to see the stroke, you can write joule meter negative 1. Faham eh? Jelas ah? Gradient divide. Area unit U times. This one. Okay, calculate area using relevant formula of the area. So this one we covered already. Okay, but for this graph, if you want to determine the area, what would be the unit for the area? This graph, joule meter. What is the unit for the area? This is unit for the gradient. This is gradient. Area? Yes. area of this graph, what is the unit? Remember? Area means times. You times. Okay, so means that the area of this graph unit will be joule meter. Bolehkah? Dah faham? Why no respond Tak ada love ke, thumbs up ke? Okay faham because if you don't respond, so I don't know whether you understand or not. Jadi cikgu pun macam tertanya-tanya. Alright, this one is quite easy. Interpolation, extrapolation. So interpolation is actually you determine the value from the graph. Extrapolation also you get the value of physical quantity from the graph, but for interpolation will be like this. You get the value from the range that is already tested during experiment. So this graph, the range class, so this is the one that is plot from the data that you have. So let's say you are asked to determine what is the value of y when x is 2.5. So here katakan. Alright, so the value is 25, some lebih kurang lah here. So when you do this action, so this is what we call as interpolation. Ataupun they ask you what is the value of x when y is 15 katakan. So y 15 is here. So you do like this. Use your ruler lah, then turun bawah. This is what we call as interpolation. Because the data here is on the graph. But for the extrapolation will be like this. Okay, so this is the graph that you have, but they ask for data of y when x is equal 0, let's say. This is x, x0 is here, but your graph did not achieve this point. So what you do is you put your ruler here and you just lengthen using dotted line. So the dotted line here means data is not in the range of the experiment data. So when you want to determine any data at this point, so this is what we call as extrapolation. Okay, just panjangkan. You need to panjangkan this, and then let's say you want to find here, right? So just touch the one that you dotted line just now. So this is the value. That is extrapolation. Boleh? Jelas? Okay, sekejap So I show you this. Alright. For physics SPM, you have paper 1, paper 2. Paper 1 will be objective question. Paper 2 will be structure plus essay question. They have format. Along the way, teachers will guide you all on how to answer the structure and essay question. Then we have another paper that we call as Ujian Amali Science. UAS, Ujian Amali Science Physics. So this is the real practical test that you need to do the experiment individually. So that's why throughout these 2 years, whenever you are asked to do experiment, most of it will be in group. So be active. You must try to set up the apparatus, must try to determine the reading to measure, to get the reading. Okay, because in Ujian Amali Science, so this one will be individual. So you must know how to do your, to conduct the experiment yourself. Okay, so for the Ujian Amali Science, the question will be either guided or not guided. Guided means the procedure are given. Okay, then you need to get the data, plot in the table and plot your graph. Tabulate your data in table, plot your graph. But if it is not guided, then you need to plan yourself. You need to write the procedure yourself. So hopefully, your during your SPM, it will be guided, will be easier. Okay, but if let's say not guided, if you used to do the experiment, it will be less difficult lah. Come, look at this. Okay, this is actually the theory, practical theory. So let's say this is the data or the graph that is already plotted. Although this is not in Form 4 syllabus, this is Form 5 syllabus, but you actually already can determine the gradient to analyze the graph. Dah boleh, ha? You see, look at this. So this is graph of R against L. Okay, R against L. So R is actually resistance, L is the length. Here, can see, the graph already show you. So the name of the symbol that we use is R. The name of the physical quantity is resistance. And then this is the unit ohm. Okay. Then horizontal axis, length, okay, centimeter. Now you see the graph, it starts from 0. And it's a straight line. So first question, get this. See that? State relationship between R and L. What is the answer? Try this first. What is the answer? What is the relationship between R and L from the knowledge that you already have just now? How should you write your answer? Look at what shape of the graph. So what is the relationship between R and L? Is it too hard? There is no Y and X. Angeli, there is no Y and X. There are R and L. This is R. The horizontal axis is L. So, change your answer, Angeli. Correct. Okay. So this is a straight line graph from origin. So the relationship of R and L is directly proportional. So the way you should write would be R is directly proportional to L because this is a straight line graph from origin. Okay, so here SPM is like this lah for your ujian amali, lebih kurang like this. Okay, so they love to ask like that. So your answer need to be complete lah, see, right? R is directly proportional to X. Bukan X, salah it should be L. Boleh? Can? Now look at this. Determine the value of L when the value of R is 2.85. 2.85. When R is 2.85, what is L? 2.85. Cikgu tulis here, takut you all lupa. Determine the value of L when R is 2.85 ohm. Betul? 2.85 ohm. Determine the value of L. So what do we call that? Is it interpolation ke extrapolation? Where is R 2.85? This is 1.5, 2, 2.5, 3, R. So where is R equal 2.85? Here will be, this is 2.75, right? 2.75, So each
Teacher,
one of these is 0.05. So means that here, correct not?
teacher, the BM1 is asking for a different number.
Is it?
Yeah.
Tak apa, okay, BM1 is easier Yalah, this one mesti ada correction. Okay lah, we follow BM1 lah, 2.75 Tak apa. Okay, we follow 2.75. So means that here. Jaden, your mata tajam boleh nampak 2.75. Good. Okay. So if let's say 2.75 like this, see from here, does it touch the graph or not? It does not touch the graph. So you cannot do interpolation. So you need to do extrapolation. So means that what should you do? Extrapolation means you need to lengthen the graph first. Panjangkan graph. You can put your ruler here. Means that you need to place your ruler here lah. So that betul-betul lurus like that. Okay. Then here you use dotted line. Understand? Use dotted line. So cikgu buat like this lah. Okay. Alright. Then this one must be shown. Mesti tunjuk. You can use dotted line, can use straight line lah. Touch, then you drag it downward. Tarik ke bawah. Okay, sampai bawah. Then here you will see the value of L at this point. Lebih kurang. Okay, this is what we call as extrapolation. Okay, jelas Clear about this or not? Not hard, right? Tak susah, right? So this one, make sure you write your answer with unit. Then look at this. Calculate the gradient. Q, they give you symbol lah. So just now we are using symbol M, right, for gradient. So actually gradient, you can use other symbol to represent gradient. It can be M, it can be K, it can be Q. Just like this, they give you as Q. See? So calculate the gradient of graph R against L, and then show on the graph how you determine Q. Now the gradient is 3 marks, 3 markah. Now, how do they give mark? So normally if the marks is 3, so tick 1 will be for the triangle, huge triangle that you draw. So mean this one mesti huge, mesti besar. If you draw small triangle, you will miss the first mark. Okay, I'm using tick 1 for the first mark. Second mark will be the value that you substitute, value, substitute. Nilai gantian, substitute. Betul ke ejaan cikgu? Okay, value that you substitute. And then the third mark will be the final answer. Final answer plus unit. Mesti ada if got unit. If no unit, you will miss the third mark. Okay, boleh But you will only get the third mark if your answer if your final answer is correct. But let's say only unit betul, no mark lah. Alright, now. So, first, you need to draw your triangle. Can you draw like this? Will you get mark or not? Will you get tick 1?
No.
No. Okay, so this is a straight line graph from origin. And the gradient is the gradient changes for this graph? Does the gradient changes? No, right? So gradient is constant. So although you draw small triangle like this, you will not get mark 1. But if you substitute correctly, you are possible to get second mark. Your final answer also will be possible to get mark. Tapi no mark 1 because your triangle is small. Okay? So to get all the mark, you better draw big triangle. So you can draw, get the easier point like this lah. So from here. Terus lukis like this. Boleh. Lukis cun-cun dah kelas. You draw this 90 degree to show that is your triangle. Okay, tandakan this. This one. Alright, so that is your triangle. So if you draw big like that, so you will get the first mark. Satu markah. Terus dapat. Only by drawing the triangle. Already get 1 mark. Senang, right? Then in the column provided just now here, so you tuliskan gradient, they use Q. So Q equal what minus what divided by what minus what. Although here is 0 kan, okay, but you need to write minus 0 lah. So here the coordinate here is 0, 0. And then the coordinate up here is 2.5 lah. I'm using this point lah. Bawah sekali berapa? 70. That 70, 2.5. Okay. So here should be, just now is coordinate 70, 2.5. Another one is 0, 0. Alright. So gradient 70 minus 0 divided by 2.5 minus 0 ke terbalik? Vertical axis is 2.5. Horizontal axis 70. So the gradient is, cikgu dah salin titik here. Sepatutnya apa? Should be correct or not if I write like this? Ataupun terbalik kelas? 2.5 minus 0 ke atau or like this? Which one is correct? Number 1 ke number 2? Okay, good. Number 1 correct. Okay, mestilah y ya. Y changes in y axis, okay, divided by changes in x axis. Okay, sepatutnya number 1 lah. So cikgu padam. Now, so this is the second mark, markah kedua. But you see, some student might see, alah, this is 0, 0, buang in je tulis. Okay, some student don't want to write padam like this. When this happen kan, you will get cross. Why? Because if you did not write minus 0, so means that for the understanding of a marker, we understand that you actually use only one point, satu titik. Means that you only use this point. Okay, because this point will be y is 2.5 divided by 70. You did not get the range. But if you put, katakanlah 2.5 minus 0 divided by 70 minus 0. So minus 0 here tell us that you use the range. So that's why, although only 0, but it has big meaning, ada maksud. You must have that. Okay, so jawapan berapa? Tekan kalkulator. 2.5 divided by 70. Okay, so your final answer, try to write in 2 to 4 decimal place or more lah. Okay, so here jawapan 0.03571 like that. Okay. So this one betul, tick 2. Okay, can we give tick 3 or not? Dah boleh bagi kah tick 3? What is missing?
Unit.
Unit, very good. Okay, so what is the unit? Okay, referring to that. Now should be semua boleh jawab dah. Ha? What is the unit for the gradient?
Ohms per cm.
Okay, this is ohm. This symbol is ohm. And then this is cm. So the unit become ohm per cm. Okay, ohm per cm. You write like this also enough. You don't macam bawa ke atas pun boleh. Like this, right? Ohm per cm. Per cm. This is already correct. Kalau takut buat careless mistake, leave your answer like this. It's okay. No need to do bawa ke atas. No need. Tak perlu. This is not compulsory. Okay? Sebab because sometimes student careless, they forgot to put this dan salah lah. Okay, so this one yang lebih lanjut, this one I don't want to teach you today lah, next time. So at least you get 90% of the knowledge for 1.2 already. So sampai here, actually you already have the knowledge on how to analyze data. Okay, analyze data. So this, we are actually focusing on how to analyze data from the graph. Okay. Okay, ada soalan? Any question?
Teacher, from the question we did just now, what if the line was slanted and the gradient keeps changing? I mean,
Sekali lagi?
for the question we did right now, what if the graph line was the gradient for that graph line was keeps changing?
Very good question. Very good, Jaden. Okay, now, so if let's say the graph is a straight line, increase linearly, decrease linearly, directly proportional, you will get the same gradient at all time because the gradient are all constant. But if let's say your graph is a curved graph, the gradient is not constant. Katakanlah, cikgu lukis here. So let's say you have this graph. Katakanlah, tiba-tiba your graph like this. Okay, curve. So if they want to ask you to determine the gradient, they will ask you to determine gradient at a specific point. Katakanlah, determine gradient. Let's say I'm just using y and x lah. So determine gradient when x is 5. So what you need to do is to determine the point. Okay, so means that they want you to determine the gradient at this point. Okay, so we actually need to use mirror. Okay, to use mirror so that the mirror can help you to draw a right angle triangle. Okay, to draw a right angle triangle. Okay, do like this. So what we do in class, I will explain again on how to determine this gradient. Okay, so we will place mirror here. Okay, and you need to adjust your mirror either to move like this or to move like this. Of course, if you move your mirror, the slanting will change like that lah. It's either like this or like this, right? Then, okay, let's say you already place your mirror here. So what you need to do is to look into the mirror. Let's say this is the back of the mirror. Okay, so the shiny part is this side. So you look at this point, and in the mirror, you will see the image of this graph. Okay, this will be very interesting. When you place your mirror, okay, the image here the object, I call this as object, and then the image of this will be appear in the mirror and as if they make a smooth curve like that. So if let's say the position of this mirror is not correct, you will see, katakanlah, in the mirror you will see something like this and then nampak macam like that in the mirror. So if you get that, what I mean is this is the on your paper, and then in the mirror you should see it continuous, smooth. But let's say in the mirror you see like this ke ataupun curve ke bawah like that, so means that the position of your mirror is wrong. Let's say you already get the correct position of your mirror. So what you need to do is to trace the mirror. Okay, trace by using like this dotted line. Okay, so the line that you draw now is actually what we call as normal. Okay, and then on the point, okay, slowly cikgu ajar, on this point, so you draw a line that is 90 degree to the normal. Like that. 90 degree. Okay, so this is what we call as tangent. Okay, then you just need to draw this horizontal parallel to the horizontal axis, then draw this parallel to the vertical axis. So you see your triangle already. Then here will be, this will be, okay, this will be changes in x-axis, and here is the changes in y-axis. So you want to calculate the gradient, same method, which means changes in y-axis over changes in x-axis. Like that. Bolehkah? Okay, means that you need to get the value here to get your changes in y-axis. And then here will be for the x-axis. Actually, seldom we see in SPM paper curve graph, because if let's say they ask you to determine the gradient, they need to provide you with the mirror. Selalu like that. Seldom lah, seldom. Yeah. Okay. Ada soalan lain? Ataupun yeah, but this is the correct way on determine the gradient of a curve graph, because the triangle actually keep on changes. Kan, like this, that is the point. If let's say this point, the triangle will be like this. Senang cikgu lukis like this now, since Jaden asked. A good question. Very good question. See, curve like that. So means that the gradient here will be, that is the triangle. Here, you see the triangle? You look at the changes in the triangle. Do you see that here, the vertical axis is getting, y changes is getting smaller and smaller. So kan gradient changes in y over changes in x. When y is decreases, so that's why we say finally your calculation for gradient will be getting smaller and smaller. So that's why curve like this, gradient decreases. But let's say curve like this. Okay, this one is actually a bit detailed. If like this, you see, triangle. Can see or not? Do you see changes in y getting more and more, semakin tinggi? So that's why curve like this is increased gradient. Increased gradient. Refer to what we have learned just now. Curve like this is decreased gradient. Decrease. Boleh faham? Okay?
Okay, teacher.
Alright, okay. I know this is not easy, but then an easier way for you to macam faham lah, either the gradient increase or decrease, is to visualize yourself running on that track. Macam cikgu ajar just now. You visualize yourself running. So this one getting harder, so increase gradient. So this one mula-mula susah, but getting easier and easier. Okay, so decrease gradient. Okay, ada soalan lain? Actually, there are one more part that I have not teach you, the tabulate data in table. Tabulate data in table. So this one, yesterday we done this halfway before the scammer come in, right? Kejap. So for the textbook, so here it shows you how to tabulate data in table. Okay. So this is the table. So you see, you need to write the name of the physical quantity, symbol, and unit. Same goes to this, the name, symbol, unit. So the title of the each column must have at least symbol of the quantity and symbol of the unit. If you can have three like this is good. Sangat bagus dah. Okay, name, symbol, unit. Name, symbol, unit. And then the first column will be for the manipulated variable, where this is normally your horizontal axis. Okay, and the range here must be constant. Constant increases, just like this, increase by 0.5. Kan? Because the manipulated variable is the data that you can fix earlier, the value you can fix earlier before you do the experiment. Okay, but for the responding variable, which is the second column here, so this one you must do experiment to get the data. But when you write the data, you see the number of decimal place. It must be consistent. Like this is 1. All must have 1 decimal place. And then here, extension of the spring, we measure the extension of the spring using meter ruler. Okay, so ruler will only let you write 1 decimal place. You unable to see until 2 decimal place. Okay, ruler only 1 decimal place. How do you determine how many decimal place should you write? Okay, this one cikgu boleh ajar sikit. Like this. Alright. This is what we discussed yesterday, right? Halfway we discussed. Sekejap, the length. So here, the meniscus. So the reading here is this part. Alright, so this is 2. Can you just write 2? Or should you write 2.0? Or should you write 2.00? Which one is correct? So to decide whether to write decimal place or not, you better look at 2 point on the measuring instrument. Just like this, 3 and 2. So what you need to do is tolak 3 minus 2. Then you divide by how many division in between these 2 points. So here you count. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So means that divide by 10. So if this is 1 divided by 10, your answer is 0.1. So means that you must have 1 decimal place. Okay, so the correct answer is this, 2.0. So you write here, 2.0. So if you write 2.0, this is correct. But if you write 2 only, this is wrong. Because decimal place in physics have meaning. It shows the accuracy of the instrument that you use. Okay, let's say you write 2.00 centimeter. Okay, in physics, okay, this is actually measured using vernier calipers. Because vernier calipers can give you 2 decimal place for centimeter. Faham? But if you write only 1 decimal place, we understand from here, we know that you are using ruler. But if you give this, we don't know what instrument do you use. Clear or not? Okay, I'll give you another example. Let's say this. This is a weighing scale, and this is the reading. So, what is the reading now? Kejap, cikgu cari yang lebih senang. Here. What is the reading now? So first, you must know how many decimal place should you write. Alright, so pick 2 point, any 2 point. You can pick this. So 0.3 minus 0.2. Divide by how many? Divide by berapa? They are increase it. Now we want to know whether to write decimal place or not. So just pick 2 point minus, then divide by how many division? So how many division are there in between that 2 point? Is it 6? Kira betul-betul? Okay, you can count like this. 1, 2, 3, 4, 5. Boleh lompat like that. Bukan 4, but 5. This is 1, 2, 3, 4, 5. Okay, jangan salah lompat. I think you count this 1, 2, 3, 4. Bukan. Don't count like that. You need to know the number of division. Okay, So divide by 5. So means that 0.1 divided by 5. So what do you get? 0.02, right? Betul kah? 0.1 divided by 5. 0.02. So if 0.02 like this means that your reading must have 2 decimal place. Okay, so it means that here is 0, the reading here, this one is 0.12. Clear tak? Jelas tak? You see, if you have any question, ask, jangan diam-diam, because this is baru masuk form 4. So don't, you don't understand, you ask. Okay, as what Chinese proverb said, right? He who asks is a fool for 5 minutes. He who don't ask will be a fool forever. So it's okay to look like fool for 5 minutes, okay, rather than fool forever, right? Jelas tak? Okay. So as for the experiment that you will do next week, like that. So can see here. So tapi this one I want to change, not for 20 oscillation, 10 complete oscillation is enough. Right, you see, they give you the name, symbol, unit. Here also the name, symbol, unit. So this is the, at least you have symbol and unit, symbol and unit. Okay, but this one will be discussed next week. Okay, ada soalan? Any question? This one also the gradient, see, but this will be discussed when we do experiment for the simple pendulum experiment, and then only I can discuss this with you all. So cadangan cikgu, next week you can already write your report. This is done by your senior using school foolscap paper. You write your name. This one yang lain boleh salin, just like your textbook lah. Okay, inference, hypothesis, aim, variable, apparatus, material, then diagram. Okay, then you see how she wrote the in passive voice. The length of the pendulum is adjusted to 20 cm. Okay, the pendulum is displaced at the angle less than 10 degree from vertical axis and release like that. Then you see the data, that are the data that she get, 20 oscillation. Okay, then the gradient, calculate gradient. Okay, and then plot graph. I actually asked student to plot 2 graph, T square against L. Another one is, this is actually T against L. This is T against L. Okay, curve graph. And then T square against L, you will get a straight line graph like that. Okay, but this one we'll discuss more. I think we can also have Google Meet for this. Okay, depends on Cikgu Jap hadir ke tak. So otherwise I will keep on conduct Google Meet with you all. Alright, so ada soalan? If no question, okay, so we can conclude today's lesson. So you already learn on the relationship of the graph. Okay, you should know what is directly proportional, inversely proportional, increase decrease, increase linearly, decrease linearly, and then how to determine the gradient of the graph and the unit, how to determine the area under the graph and the unit, how to interpolate graph, how to extrapolate graph. Okay, that you already know already. Okay. All right, so I think I off recording. Okay, so hopefully what you have learned today, you understand and you can apply. I off recording first, don't go yet. Okay, cikgu off recording.